This is an illustration of the general profile of a river system with the idea we have our steeper gradient, our headwaters, in which we're going to typically have more of a V-shaped valley. And we don't have many of these in Indiana, but we do in the upland areas of south central Indiana. If you go to Brown County or you look at aerial images of the Crawford and Norman upland, you will definitely see a bunch of V-shaped valleys as streams continue to downcut and create a very particular pattern in terms of these fluvial processes, these landforms created from rivers. And another characteristic that you'd find up there in the headwaters, up there in the more steep gradients, are very minimal floodplain. What I mean by that is you're not going to see a large floodplain that stretched from way from one side way to the other like you might find there in southwestern Indiana, as I'll showcase later on. Although we don't really have these in Indiana, but this is where you would find more of those rapids or falls. But unfortunately, in Indiana, we do not have enough water flow to have whitewater rafting. And so we think about also the sediments that are left behind as we progress. And so up there in these steeper portions is where you're going to have our bigger boulders and stones and gravel left behind. And as that river continues to flatten, the sediment that it can lay down also starts to get smaller and smaller and smaller. So here we have, this, let's say this is sand, can no longer be carried anymore because the river flattens out, and then now all left is the clays, because the clays are small enough sediment. So the idea is how, once again, rivers do a good job of sorting. This is another example to showcase that. As the river goes from its source down to its destination. Now, it's also important to keep in mind when we think about gradient, as far as this is where erosion is going to take place, is where we're going to find steeper slopes. And for erosion to occur, you must have water moving at a fast enough pace. Eventually, though, it's going to be not moving at enough pace. It's essentially going to lay down the sediment. So that's where we see deposition. So erosion removes, deposition lays down. This schematic here is a representation of a V-shaped valley in which we have our stream. This is the cross-section view. So this is essentially, we cut right through the middle and we're looking at the side view of a river. What the red dot is illustrating is where we would expect the fastest velocity or the fastest pace of this stream to be. It's going to be always above the deepest part of the channel, just below the surface. And right where this red dot is. And so the deepest part, right above it, but also just below the surface. Just below the surface, because of friction at the surface is going to cause this, the atmosphere, wind, whatever, is going to cause it to be a little bit slower. And so there's tension there, and so there's friction there, and so the fastest velocity is going to be just below the tip of the top. And so what we have here is we can visualize as this particular river meanders, it's going to change its course. And so we think about where would the fastest pace be on this particular case? Once again, above the deepest part of the channel. And so we're going to come back to this particular idea, but we have a steep slope. This is a very typical pattern of the meandering streams of Indiana. We have a steep side and a not so steep side. So what happens here as this particular river meanders is these faster velocities are going to be over here on the outside, over here closer to the steep side of this particular river, and so it's going to continue to erode away, remove away, and create this deeper channel on this particular steep side. Of course, when the river meanders, this all switches to the other side. And so here, deepest part of the channel, just below the surface, that's where we're going to find the fastest velocity.